Hi and welcome back to Sustainable Teacher. If it is your first time here, my name is Leticia and I'm glad to meet you. And if you've been here before, I'm happy to see you again. In today's video, we are going to talk about parallel circuits. So circuits with components in different wires, and these wires are parallel among them. If this video sounds interesting to you, please subscribe, hit the notification bell, and if you like this video, give it a thumbs up. In previous videos, we talked about what is electricity, and general information about circuits, electric circuits, and we also learned about how to apply the Ohms formula in simple circuits and in series circuits. But as I told you in the first video, usually electric devices at home, they are not made with series circuit. Usually they use parallel, or sometimes, and that's the majority of cases, they use mixed circuit with some parts in series and some part in parallel. So today we are going to focus on parallel circuits. So as always, what we are going to do, stop please. So as always, what we are going to do is to apply the Ohm's law in a parallel circuit. Just to remind you, the Ohm's law is the equation that relates the three main data that characterize a circuit, which are resistance, intensity, and voltage. As always, remember, the definition of voltage is the difference in energy potential, like the difference in charge between 2 points of the circuit in a moment. The intensity is also called current, but it can be confusing with electric current. The intensity is the rate, like the number of electrons passing through a point in a circuit at a certain time. And the resistance is the tendency or the ability of any component in the circuit to resist, to avoid the pass of the electricity of the current through that point. It's like a car, I told you before, in a road, when the friction between the car and the air, or the tires and the road. The way to relate these three values is with the Ohm's law, and the equation usually is represented as B equals to I multiplied by R. Remember that B is voltage and is measured in volts. I represents the intensity and is measured in amps or amperes. And the resistance is the R and is measured in ohms. And the symbol is an omega. I think I've never said this in the two previous videos. Oh boy. You know, omega is the Greek letter. Okay? So the thing is that we can isolate each of these values to calculate it, and as in any equation, if we want to isolate the I, we have to change to the other part of the equal, the R, and as it was multiplying, now it's gonna be dividing, and if we isolate the R, it's the same for the I, okay? So now that we remember this thing, we are going to apply this formula in parallel circuits. Just to remind you again, usually when we work with parallel or series circuits, what we have to add usually are resistance or resistors. So just to remember that there are different types of resistors, like thermal resistor, light resistors, and the basic ones, they have like a color code with rings with colors. And each color represents the amount of resistance, the amount of voltage that will be resisted at that point. Okay, that is interesting if we have like a really big circuit in electric device, and there are some parts that are more delicate than others, and we cannot make the electricity go like all at the same time at that point. We use resistors to make it go like slower, okay? So as I told you, parallel circuits are circuits in which their components are in different wires, and those wires are parallel among them. And to apply the Ohm's law, we have to calculate, as in the series circuit, the total values for voltage, resistance, and intensity. And it is a bit different and maybe a bit more difficult than in series circuits. Okay, so let's see it. In a parallel circuit, all the energy starts in the power supply, that could be a cell or could be a battery, and it will go through the wire, and when the wire divides in more than one wire, electricity will divide among those wires, okay? So the thing is that in this case, the intensity changes, because of course the rate, it can be the same in the main wire and all the parallel wires. So the intensity, in this case, we have to add it as we did before with the voltage or with the resistance, and it's just a simple add. You add all the independent intensities in your parallel wires and you will have the total value. And in this case, the thing that doesn't change, because there in this formula, I haven't told you this before, but it might be one constant value. So if voltage changes, intensity should be constant. In this case, if intensity changes, voltage must be constant. So in this case, voltage is always the same in any point of the circuits, okay? So you don't have to add it, it's just the same always. And finally, resistance. In the case of resistance, we have to add, but it's a bit special. It's not like a normal add. We are going to add the inverted value of resistance. It's because you have like a total resistance in your circuit, but as you are splitting it in different wires, you are dividing it somehow, and that's why this is like this. To calculate the total resistance, you have to all the resistance value inverted and then invert the total value to get that value, okay? So let's do this and you will understand it better with an example. So imagine that we have a circuit like this with two resistors, okay, in parallel and a cell. We know that we are going to, in this case, we know the total value of the voltage, which is 12 volts. And we don't know the intensity, and it said that this is resistor 1 and the resistance in this resistor is 3 ohms, and this is resistor 2 and the resistance in this resistor is 6 ohms. So the thing is that to calculate the total intensity, we have to guess to calculate the total resistance before, because you know that the formula is going to be total intensity is equal to total voltage divided by total resistance. And as we don't know the total resistance, is the first thing that we have to calculate. So we know that 1 divided by total resistance is the way of calculating it, and then we will invert this value to have the final value, okay? So 1 divided by resistance 1 plus 1 divided by resistance 2, I was going to write 2. So that is 1 divided by 3 plus 1 divided by 6. And as you know, when we have fractions with different denominators, we have to calculate what is called in English the greatest common factor, okay? So the greatest common factor is always where we have to decompose the numbers. You already know this, so we are going to do this too fast. That's for 6. 3 is already a prime number. So in this case, factors are 3 and 2, okay? So we are going to make 6 in here. The first one must be multiplied by 2. The second one doesn't change. And now we can calculate the total resistance. I don't have space. So this is 3 divided by 6. Of course, we can simplify the fraction. So let's do it in here. So we have 1 divided by the total resistance is 3 divided by 6. That means 1 divided by 2. So as you know, this is the inverted resistance. So if we invert, what we have to do to get the final resistance is doing 1 divided by 1 divided by 2. So as you know, what we have to do is to multiply this and divide by this. So that is 2 with divided by 1, which is just 2. So the total resistance is 2. And now we can calculate the final formula for the total intensity that we don't know. So that is total voltage divided by total resistance, total resistance, which is 12 volts. I said 12 volts, come on. 12 volts divided by 2 ohms. I forgot to include the ohms in here, by the way. So that is 6 ohms. And that's the final result of our exercise. And that's it for today. I hope that now you understand better how to apply the Ohms formula in a parallel circuits. It's a little bit more complicated than more complex than series circuit. We just for the way that we have to add resistance, we have to invert them and get the total value inverted, and then invert it again to have the final total resistance value to apply it in the Ohms formula. Leave in the comments if you don't understand something about this or you have any doubts, and of course, see you soon.